The National Electrical Code (NEC) requires that high-intensity discharge (HID) lamps, other than thick glass parabolic aluminized reflector power type lamps, must be enclosed in a barrier or use only a Type 0 lamp. This is because high-intensity discharge (HID) lamps that are left on continuously 24 hours a day, 7 days a week can overheat and explode, potentially causing fires. Type 0 high-intensity discharge (HID) lamps have a longer neck than other types of high-intensity discharge (HID) lamps. When a non-Type 0 lamp is screwed into a socket designed for a Type 0 lamp, it will not make contact, preventing the lamp from operating. The NEC requirement for high-intensity discharge (HID) lamps was added because of the potential for explosions when high-intensity discharge (HID) lamps are left on continuously. When high-intensity discharge (HID) lamps overheat, they do not reach their normal end-of-life condition, where they typically go out and instead explode. For example, one of the high-intensity discharge (HID) lamps in a commercial garage that was left on 24 hours a day, 7 days a week, exploded. To prevent high-intensity discharge (HID) lamp explosions, it is recommended to turn off high-intensity discharge (HID) luminaires for 15 minutes each week. This allows the lamps to cool down, which reduces the risk of overheating and explosion when they reach their end of life. The specific section of the 2005 NEC that addresses this is Section 410.76. It outlines requirements for electric discharge lighting systems operating at greater than 1000 volts. It mandates that lamps be equipped with an enclosure that protects against contact with the lamp during operation and prevents debris from falling onto the lamp. This enclosure is a key safety measure to contain potential explosions. The requirement for a barrier or the use of Type 0 lamps specifically targets open or inadequately enclosed high-intensity discharge (HID) lamps, which pose a greater risk of explosion and fire. In the case of a high-intensity discharge (HID) lamp exploding, the barrier would contain the hot fragments of glass. If there is no barrier, this could start a fire. Understanding Type 0 lamps, they have a longer neck that prevents other lamp types from being used in the same socket. This design ensures that only lamps with appropriate safety features are installed. The reason for the NEC focus on this issue is rooted in the inherent characteristics of high-intensity discharge (HID) lamps. These lamps generate light by passing an electric arc through a gas-filled chamber. The gas is often under high pressure, and the temperatures inside the lamp can be extremely high. Over time, the lamp's components degrade, and the pressure inside can increase. If the lamp is continuously operated without a cooling period, this degradation accelerates. Eventually, the lamp may reach a point where it can no longer contain the pressure, leading to a violent explosion. The consequences of a high-intensity discharge (HID) lamp explosion can be severe. Hot glass fragments can be ejected over a wide area, posing a significant fire hazard. These fragments can ignite flammable materials such as paper, cardboard, or textiles, leading to a rapidly spreading fire. Additionally, the explosion can damage nearby equipment and structures. The NEC recommendation to turn off high-intensity discharge (HID) luminaires for 15 minutes each week is a practical and effective way to mitigate the risk of explosion. This brief cooling period allows the lamp's components to cool down, reducing the pressure inside and slowing down the degradation process. While 15 minutes is a suggested duration, the actual cooling time required may vary depending on the specific type of high-intensity discharge (HID) lamp and its operating conditions. Consulting the lamp manufacturer's recommendations is always a good practice. In addition to the weekly cooling period, other preventative measures can be taken to reduce the risk of high-intensity discharge (HID) lamp explosions. Regularly inspecting high-intensity discharge (HID) lamps for signs of damage or deterioration is essential. Look for cracks, discoloration, or other abnormalities. Replace any damaged or deteriorated lamps immediately. Ensure that high-intensity discharge (HID) lamps are properly installed and maintained. Follow the manufacturer's instructions for installation, operation, and maintenance. Use the correct type of lamp for the fixture. Never use a lamp with a higher wattage than the fixture is designed for. Also, be aware of the ballast. The ballast regulates the flow of electricity to the lamp. Make sure the ballast is compatible with the lamp and is functioning properly. A faulty ballast can cause the lamp to overheat and explode. Lastly, consider replacing older high-intensity discharge HID lamps with more energy-efficient and safer alternatives such as light-emitting diode, LED, lighting. Light-emitting diode, LED, lighting offers several advantages over high-intensity discharge HID lighting, including longer lifespan, lower energy consumption, and reduced risk of explosion. Light-emitting diode, LED lamps do not contain pressurized gas, so they are not susceptible to the same type of explosion hazard as high-intensity discharge HID lamps. They also generate less heat, which further reduces the risk of fire. When replacing high-intensity discharge HID lighting with light-emitting diode LED lighting, it is important to consider the lighting requirements of the space. Light-emitting diode LED lamps are available in a variety of wattages, color temperatures, and beam angles. Choose light-emitting diode LED lamps that provide the appropriate level of illumination for the application. In summary, the NEC requirements for high-intensity discharge HID lamps are designed to protect people and property from the hazards of high-intensity discharge HID lamp explosions. By understanding these requirements and taking appropriate preventative measures, you can significantly reduce the risk of high-intensity discharge HID lamp explosions. Remember to turn off high-intensity discharge HID luminaires for 15 minutes each week, inspect lamps regularly, and replace damaged or deteriorated lamps promptly. Consider replacing older high-intensity discharge HID lamps with light-emitting diode LED lighting for increased safety and energy efficiency. Another important aspect to consider is the role of the electrical contractor in ensuring compliance with the NEC requirements. When installing or maintaining high-intensity discharge HID lighting systems, electrical contractors should be knowledgeable about the NEC regulations and follow them carefully. They should also be able to identify potential hazards and recommend appropriate solutions. Electrical contractors should also educate their customers about the risks of high-intensity discharge HID lamp explosions and the importance of preventative measures. This can help to ensure that high-intensity discharge HID lighting systems are operated safely and that the risk of explosions is minimized. Furthermore, regular inspections of electrical systems, including high-intensity discharge HID lighting, are crucial. These inspections can identify potential problems before they lead to serious hazards. Inspections should be performed by qualified electrical professionals who are familiar with the NEC and other applicable standards. The frequency of inspections should be based on the type of high-intensity discharge HID lighting system, its operating conditions, and the environment in which it is located. In harsh environments, such as those with high temperatures, humidity, or vibration, more frequent inspections may be necessary. In addition to the NEC, other organizations, such as the National Fire Protection Association (NFPA), also provide guidance on the safe installation and operation of high-intensity discharge HID lighting systems. These guidelines can be a valuable resource for electrical contractors, building owners, and facility managers. It is important to stay up to date on the latest codes, standards, and best practices for high-intensity discharge HID lighting. This will help to ensure that high-intensity discharge HID lighting systems are installed and operated safely and efficiently. Finally, it is worth noting that the technology of high-intensity discharge HID lighting is constantly evolving. New types of high-intensity discharge HID lamps and ballasts are being developed, and new safety features are being introduced. It is important to stay informed about these developments and to evaluate their potential benefits and risks. When considering new high-intensity discharge HID lighting technologies, be sure to consult with qualified electrical professionals and to follow all applicable codes and standards. They include firstly, metal halide, secondly, high-pressure sodium, and thirdly, mercury vapor lamps. Each of these types has its own specific characteristics and safety considerations. For example, metal halide lamps are known for their high light output and good color rendering, but they also have a higher risk of explosion than some other types of high-intensity discharge HID lamps. High-pressure sodium lamps are known for their energy efficiency, but they have a poor color rendering. Mercury vapor lamps are less common today due to their lower energy efficiency and the environmental concerns associated with mercury. When selecting high-intensity discharge HID lamps, it is important to consider the specific requirements of the application and to choose the lamp type that best meets those requirements while also providing adequate safety. Consider the ambient temperature in which the high-intensity discharge HID lamp will be operating. High-intensity discharge HID lamps are sensitive to temperature, and their performance can be affected by extreme temperatures. Some high-intensity discharge HID lamps are designed for use in specific temperature ranges, and it is important to choose a lamp that is appropriate for the environment in which it will be used. Consider the voltage requirements of the high-intensity discharge HID lamp. High-intensity discharge HID lamps require a specific voltage to operate properly. It is important to ensure that the voltage supplied to the lamp is within the specified range. Using a lamp with the wrong voltage can damage the lamp or the ballast. It can also create a safety hazard. Consider the ballast. The ballast is an essential component of a high-intensity discharge HID lighting system. The ballast regulates the flow of electricity to the lamp and ensures that the lamp operates properly. It is important to choose a ballast that is compatible with the lamp and that is designed for the specific application. Also, consider the enclosure for the high-intensity discharge HID lamp. The enclosure provides physical protection for the lamp and helps to contain any debris in the event of an explosion. The enclosure should be made of a durable material and should be properly installed. Check the wiring. Inspect the wiring connections to the high-intensity discharge HID lamp and ballast. Ensure that the connections are secure and that the wiring is in good condition. Loose or damaged wiring can create a fire hazard. Consider the grounding. Ensure that the high-intensity discharge HID lighting system is properly grounded. Grounding helps to protect against electrical shock and can also reduce the risk of fire. Consider the maintenance. Develop a regular maintenance schedule for high-intensity discharge HID lighting systems. This schedule should include inspections, cleaning, and lamp replacements. Proper maintenance can help to extend the life of the system and to ensure that it operates safely. The risk can be further reduced by turning off high-intensity discharge HID luminaires for 15 minutes each week, inspecting lamps regularly, and replacing damaged or deteriorated lamps promptly. By following these guidelines, you can significantly reduce the risk of high-intensity discharge HID lamp explosions and create a safer environment for everyone.